guys, I hope you all are doing good. I'm Vaishali Kekant and we are discussing the measurements and the data processing unit. So let's start our discussion with the first question of the day, which states the mass spectrum below is for a compound X that contains C, H and O, carbon, hydrogen and oxygen. The infrared spectrum of X has an absorption band at 1725 centimeter inverse. So the first part is what is the relative molecular mass of X? Given that X contains 2 oxygen atoms, suggest the molecular formula of X. Identify which group is lost from the peak marked at B. Suggest the identity of species responsible for peak A. Calculate IHD of X. Deduce structural formula of X. So we have to solve all of these parts. So let's start with A. Now we have to find out the relative molecular mass. So we can use the mass spectrum. You can see we have the mass spectrum. Now the peak at highest M by Z value represent the molecular ion. So now the relative molecular mass would be 136 because the last peak over here you can see it is at 136. So M by Z highest value is 136, which represent the molecular mass. So molecular mass here is 136, and from that if I know it contains 2 oxygen atoms, now the second part ask us to find out the molecular formula of X. Now we know the molecular mass, we know there are 2 oxygens. So the 2 oxygens will be having the mass equal to 16 into 2, that is 32. So the only formula which contains the 2 oxygen and the 32 mass of 2 oxygen and 136 as the molecular mass is C8H8O2, right? Because we have 2 oxygen, 32 mass, and the remaining mass would be 104. Now when I have 104 as the mass of carbon and hydrogen, we can have various combination. Let's suppose instead of 8 carbon, I am moving with the 7 carbons. So I have 7 carbons, which means the mass of the carbon atom would be 7 into 12, which is 84. The mass of the remaining would be the hydrogen mass. So remaining mass is 104 minus 84, that is 20. So we have 20 hydrogen atoms and 7 carbon atoms and 2 oxygen atoms. But there is a problem. The alkane with 7 carbon will be having at most 16 hydrogen only. So the formula C7H20O2 is not at all possible. So what possibility we have? We have 8 carbon, right? So 8 carbon is there, then 2 oxygen is there, then only number of hydrogen we need to calculate from the molecular mass, then we can calculate it, it would be 8. Right. So now coming to the third part, identify which group is lost to form the peak marked at B. So if I see the peak marked at B, the M by Z value is 105. So now if I remove 105 from 136, which means 31 is removed. So now the 31 is removed, which means what is removed from here? CH3O is added up to form the 31. Right. So which means OCH3 is the ion which is removed to give the peak at 105, right? So CH3O is lost from the molecular ion to produce the B. Coming to the peak A. Now we have to find out the group which is lost to form the peak at A, right? So now the peak at A will be having the M by Z value 77. You can see it from the diagram. And now the fragment possible for 77 value is C6H5 positive, right? So now here coming to the IHD. IHD is having the formula half of 2C plus 2 minus H minus X plus N. So here C represents the carbon atoms. The formula for any compound would be CCH, and NOOXX. So C represents the number of carbon atoms, H represents the number of hydrogen atoms, N represents the number of nitrogen atom, O represents the number of oxygen atoms, and X represents the number of halogen atoms, right? So the molecular formula here is C8H8O2, right? So here you can see, now here we have HC is equal to 8, H is equal to 8. So now when I put it over here, because O is not contained in this IHD formula, we have to not consider the number of O, right? So we have C as 8, H as 8. So when I put the values of C and H over here in this formula, we will be having IHD as half of 2 into 8 plus 2 minus 8, which is 5. So now here IHD is 5, which means we will be having 5 double bonds, right? Or we will be having the benzene ring, right? In the structure, I have to now deduce the structural formula. This is the last part. So benzene ring is proposed. Why? because here IHD would be 4. Why IHD is 4 for the benzene ring? 1 IHD is for the ring and 3 IHD for the 3 double bonds that are present in the benzene. Apart from benzene, we have one more double bond, because here we have 4 IHD for the benzene, but total overall IHD of the structure is 5. So we have either one more double bond or we have one more ring. So now M by Z is 77, which again represent the benzene ring at one location, right? Loss of 31 mass represents OCH3 group. So here you can see when I have O, here we will be having a double bond O as well, because we have O here as 2, right? So you can see over here CH8O2. OCH3 is present and other O is present with the double bond, which is making the IHD equal to 5. So absorption band is present at 1725 centimeter inverse. Also, this is also given in the question itself. So it also suggests that we have C double bond O group. And from the IHD also we had seen that we had C double bond O group. So you can see the structure. This is the possible structure, benzene with C double bond O, OCH3. I hope you understood this question. Coming to the next question. An organic compound Y is shown by the elemental analysis to contain only carbon, hydrogen and oxygen. The following information about Y is available. First, mass spectrum. The molecular ion peak occur at M by Z at 86, right? Then IHD is given as 1. Infrared spectrum is also given, you can see. Nuclear magnetic response spectrum will be having 2 peaks. One at quartet, which is having delta is equal to 2.4 ppm, and one triplet where delta is equal to 1.1 ppm. Now we have to determine the structure of molecule from this data. So the possible combination for the peak at M by Z is equal to 86. M by Z is given here, it is 86, right? So now here when I have 86 M by Z and I need to find out all of the possible combination for carbon, hydrogen and oxygen, we will be having 3 possible combinations: C5H10O, C4H6O2, C3H2O3, right? Now I know the IHD also. IHD data is given, it is 1. So IHD, we know the formula, half 2C plus 2 minus H minus X plus N. Now I hope you know all of these things. For all of these 3, we are going to find out the IHD. So C5H10O will contain 5C and 10H. So half of 2 into 5 plus 2 minus 10, which is 1, right? So here IHD is 1 and IHD given was also 1. So this is the right molecular formula. For the other 2 also we calculated it. C4H6O2 will be having half 2 into 4 plus 2 minus 6, because the number of carbon atoms is 4, the number of hydrogen atom is 6. So it is giving me IHD is equal to 2. For C3H2O3, IHD will be equal to 3. Half of 2 into 3 plus 2 minus 2 will be equal to 3. Right, so one thing is sure that C5H10O will be the molecular formula. Now we have to find out the structure from the molecular formula, right? So infrared spectrum, now we will observe, we have the absorption band in 700 to 750 centimeter inverse, which means we have a C double bond O group in aldehyde, ketone, carboxylic acid or ester. So C double bond O group is present, which is present in all of these 4. But you can see in the molecular formula, we have only one oxygen. C5H10O is the molecular formula. We have only one oxygen atom. So ester or carboxylic acid would not be there at all, right? They are ruled out because we have only one oxygen atom. But these 2 structures will be having 2 oxygen atoms. Now we have to find out either it is a aldehyde or it is a ketone. So now the NMR structure will be having, you can see from the NMR structure, only 2 different environment for hydrogen atom in the molecule is present, but actually we can have infinite number of isomers, right? Below structures have only 2 different chemical environment for protons. So these 2 structures are proposed because from the NMR spectrum we know only 2 different environment for the hydrogen atoms in the molecule are present. So these 2 structures would be there, and now we will observe from these 2 structure which is R structure, right? For that we will be observing the splitting pattern for NMR data, right? The splitting pattern for NMR data